Well, you may have cruised through 1 through 8 and then gotten to number 19, A and B, and thought, wow, this is kind of hard. Well, I hope you didn't feel that way. I hope you at least gave it a shot. And it's important, though, that you are able to do these problems, because these are the ones that kind of like really count. This is why you learn 1 through 8 and how to do 1 through 8, so you can do problems like this, because this is really what you want to find out. You need an equation of a line. You want to use that equation of the line to do something else. But anyway, this is kind of where it's all at here, is learning how to find the equations of the lines and applying what you're learning. Okay, and so anyway, just to kind of give you an idea of what we're doing here, we've got the graph of y equals the tangent of x. And remember, tangent of x being sine x over cosine x has zeros whenever the sine of x is equal to 0 and sine of x is equal to 0 at x equals 0, pi, 2 pi, and so forth. And so that's where we have x-intercepts, right? So we have 0, we have pi. These are x-intercepts for the tangent, 2 pi, and so forth. It's when the sine is equal to 0. So this is a really good exercise to remind ourselves, what the graph of the sine or the tangent looks like. Now, you're going to have vertical asymptotes. So vertical asymptotes when the denominator is equal to 0. So when the cosine is equal to 0. So that's when the x value is, gosh, I'm trying to zoom in here a little bit for myself so I can write it neater. Let's see here. So when the x is equal to, you've got pi over 2, 3 pi over 2, and so forth. So when x has those values, we're going to have vertical asymptotes. And so we're going to put vertical asymptote right here. That's at pi over 2. And then you've got your 3 pi over 2 vertical asymptote, negative pi over 2, and so forth. So those are your vertical asymptotes for the tangent graph. And then we know what the tangent looks like. Okay, so just like that. Okay, and so forth. So we can... don't really need all that, just helping you out there with understanding how to graph those. Let me give you guys a different color here, but what we want to do is find the equation for the line tangent to the graph of this function at the point pi over 4 comma 1. Now we know that pi over 4, let's do it in a different color. I need a better color. So right here where x is equal to pi over 4, we've got this point right there on the curve, and apparently that's 1 unit high. In fact, if you plugged in tangent of pi over 4, calculated that, you get 1. So yes, it is 1 unit high. And then we have a line that's tangent to the graph right there at pi over 4, 1. So we have that point right there. All we need is the slope equal, well, I don't know, what is the slope there? It's definitely a positive number. In fact, the slope's always positive on the tangent graph, but we don't know what that positive number is. And so I'm going to go to the next, actually let me do this. Let's erase this stuff over here so we can have some room to work. And anyway, in fact, we don't need much of that, so we'll just kind of erase that, give ourselves some work room here. But what we really want to know is what's the slope right there, and the slope specifically at that point right there. And to get the slope, we need to find y prime. So let's do that. So y prime, if y equals the tangent of x, y prime is the secant squared of x. Well, it's a little bit easier to figure it out if we write it as secant of x squared. And so nevertheless, what we really want here is y prime when x is equal to pi over 4. And y prime, or the derivative of the tangent, when x is equal to pi over 4 is the secant of pi over 4 quantity squared. Okay. Well, we know the secant is 1 over the cosine. We know the cosine of pi over 4. Cosine of pi over 4 is equal to radical 2 over 2. So therefore, the secant of pi over 4 would be 2 over radical 2. Okay? And when we square that, we get 4 over 2 which is 2. So we know that the slope right here, this is the slope we were looking for, we know the slope is 2. Right there. Knew it was a positive number, but the slope is 2 because of what we just figured out. And if we know the slope is 2, then all we have to do is use the point-slope form of a linear equation, y minus y1, and y1 is 1, okay, equaling slope is 2 multiplied by x minus x1. And x1, or the x-coordinate, is pi over 4, and so therefore we have the equation of the tangent line at that point, and hopefully seeing the picture helps you understand the concept a little bit better. Alright? But now we're going to switch gears here. We're going to do 19b. Okay, 19b, we're trying to find the equation of the tangent line to the graph of the inverse tangent of x at the point 1 comma pi over 4, which is kind of cool because it reminds us that, let me do this, let me get black here. It reminds us that how inverse tangents, or how inverse and regular functions and their inverses are related. Okay, so let me do this like this. I need some work room. So you should remember that the inverse tangent, now this is not something that everybody remembers, but it is a really good, helpful thing to remember, that the inverse tangent's graph, and I know this because it's in this packet that you guys are going to be getting in AP Calculus, inverse tangent's graph looks like that, where the asymptotes, remember the restricted domain of the regular tangent function is negative pi over 2 to pi over 2, so therefore the range of the inverse tangent, so this is y equals the inverse tangent of x, so the restricted domain of the tangent is, like I said, negative pi over 2 to pi over 2, therefore the range of the inverse tangent is what I just said, negative pi over 2 to pi over 2. And so we have this point out here somewhere. Now let's use that use that green again. So right out here somewhere, halfway up between 0 and pi over 2 would be our pi over 4 value, and then therefore that 1 would be the x-coordinate of that point. So here we have this 1 comma pi over 4. Now, kind of an interesting way to do this. We don't really have to find the derivative of the inverse tangent. Okay, and I'll tell you why. Every point on the tangent has a corresponding point on the inverse tangent. In other words, see this point right here that has coordinates pi over 4 comma 1. I'll show you the shortcut way if you can really understand it. It takes more of understanding, but it's a lot less work. So the point pi over 4 comma 1 has a slope of 2. Okay, well, on the inverse tangent graph, the corresponding point that we have here is when you just flip-flop the coordinates, 1 comma pi over 4, but it has a slope that's related, and I'll show you why, or I'll show you how we get that here in a minute. But the slope here is going to be just the reciprocal of the slope of the corresponding point. So I already know that the slope here is going to be 1/2. Okay, we can talk more about that in class, but let's just say you didn't know that and you wanted to just do all the math. Well, you could do that. You just have to find the derivative of the inverse tangent of x, and the inverse tangent is 1 over 1 plus x squared. Okay. Well, the inverse tangent then at 1, when x is equal to 1, is equal to 1 over 1 plus 1 squared, which is 1 over 1 plus 1, which is 1/2. So as I said, the slopes are related between the corresponding points. Nevertheless, this is a pretty easy one to do anyway. You didn't really have to remember that the slopes are related, and so you can just sorry, I was going to come up with the equation of the line. Using the point-slope form of the linear equation, the slope of the tangent line to this curve is y minus y1, which is y minus pi over 4, is equal to 1/2 times x minus x1, and x1 is 1. And so there you go. There's the equation of the tangent line to the graph of y equals inverse tangent of x at the point 1 comma pi over 4. That's it. That only took 10 minutes. and my dogs are still alive. Have a great night.